Okay, I'd like to ask everybody a question. And the question is quite simple. How many of you think climate change is an existential threat if we don't change our behavior? That is to say, can it lead to the complete destabilization of civilization and perhaps even the extinction of humankind? How many of you think that's a possibility? Oh my goodness! All right, well, I have to tell you, you guys are really an exception. Because for the most part, if you look at the polls around the globe, you'll find that the idea that climate change could cause any really serious problem, other than kind of what we're feeling now, is quite rare. The concept that climate change could actually cause major destabilization of civilization is not an easily accepted concept. And yet, it's very important to think about it that way, because if we don't change our behavior, and I would say very soon, then all of that is essentially locked in. The globe is such a huge system, and it has so much inertia. Once it gets going, it's really hard to change it. The momentum that it begins to set into place gets settled, and then it's really hard to change. Let me give you a quick example. If you put a great big pot of water on the stove and you turn it up to high, 3 minutes later you put your hand in, not a big deal. 5 minutes later, put your hand in, not a big deal. 7 or 8 minutes later, oh, it's starting to get warm. But if you leave it in long enough, it starts to boil, okay? Then take it off the burner. 5 minutes later, you can't put your hand in. 7 minutes later, you still can't put your hand in. Probably half an hour later, it's still warm, still even hot. So that is the kind of thing that is a part of what's going on with the global warming. And the reason for that is most of the world is covered with an ocean. It's like a gigantic pot of water. The other part that's interesting about that whole concept is that it starts slowly. And you don't really notice it at first. And it just kind of gets started. And yet, after a while, you can't really stop it. So that's what I'm going to be talking about in a sense, but it's in the context of something else. So I want to start off with the notion that climate science has really been around for a very long time. We know what it does, we know how it works, and we're just now starting to see some of the effects of it with increasing drought, increasing floods. The two are not disconnected. The warming is starting to happen. Hurricanes, I mean, there's a couple of really bad ones this year, last year. This year there are 7 major storms all the way across the Atlantic and the Pacific, all at once. 7 major storms. So it's happening. But what about the climate science itself? Well, you know what? It's really old knowledge. 1896, there's this neat guy by the name of Svend Arrhenius who was able to define the fact that carbon dioxide acts as a filter or a stop for infrared rays as they radiate up from the warmed earth that has been warmed by the sun, and it captures the heat and then re-radiates it almost right away without warming up. And that process is called greenhouse gas. Not a particularly great name, but it's what it's called. And that process tends to trap the heat in here. So the more carbon dioxide you have, the more it traps the heat. This was the first guy who was able to define that and to suggest that if we emitted too much carbon dioxide, that would actually ultimately lead to global warming, and it could be a lot of global warming. So that was 1896. 1988, a fellow by the name of James Hansen, whom you may know, spoke to Congress. Well, he did it on the basis of a paper that he prepared in 1981. And the paper in 1981 talked about the idea of global warming, and he proposed a series of charts in which he suggested that depending on what people decide to do about carbon dioxide, we would have, and he defined it in a chart. And he said that that global warming could become problematic. That was 1981. In the same years, 1982, Exxon and Shell also knew that this was going on. In fact, their researchers had warned the executive group of Exxon and Shell that the increasing amount of carbon dioxide that was a result of the work of Exxon and Shell, that is extracting carbon fossil type fuels and burning them, would cause significant increase in the temperature. The Exxon researchers suggested that by 2060, we could have as much as 560 parts per million of carbon dioxide in the air. If we did, that would lead to about 3.2, 3.3 degrees of increase of temperature, Celsius degrees increase of temperature. They also predicted that with that amount of increase in temperature, the ultimate rise would be around 1 meter for somewhere in that level of sea level. So as long ago as 1981, 1982, scientists really knew all about this stuff. 1988, James Hansen spoke to Congress, and he made the same sort of presentation. But he was basing that on the 1981 paper. The 1981 paper also suggested that it would take about 30 years before ordinary people would be able to see the effects of climate change. Well, if you think about that, 1981 plus 30 years, 2011, 2018 today. So we really have only seen the effects of climate change for 7 years. And what does that mean? That means that we are on the very leading edge of what's going to happen, because climate change, even no matter what we do, is going to go on for 100 years or more. So we're just really starting here. Congress took advantage of it, and they actually did a whole bunch of things. But one of the things that happened as a result of all that was that there was a United Nations meeting, and this was in the late 1980s and early 1990s. We formed the United Nations group on climate change, and this particular segment of it is called the Intergovernmental Panel on Climate Change, IPCC. The IPCC is basically intended to collect the work of hundreds, literally hundreds, maybe even thousands of scientists that have already been published. And that work is then formulated into a series of reports. The reports are now in their 6th generation, and they are, after the scientists have done their work, they are then reassessed by bureaucrats and rewritten in the format that politicians can use. That's the purpose of those IPCC concepts. So then the politicians are, in that sense, through their bureaucrats, made aware of what the findings of the IPCC are. These are top-level politicians. So we're in our 6th generation now. So the next stage is to ask ourselves, well, okay, that sounds really good. You know, everybody knows what's going on. The scientists have known for years. There's lots of information out there. Well, it didn't really quite go that way, because the scientists in Exxon and Shell were shelved, essentially, and there's now a complete record of the what do we call it, the executive directives to the staff of the public relations group within those two companies to focus not on the changes that climate change would incur, but instead on the uncertainty of the knowledge of this. The idea being to undermine the nature of the predictions to make less certain the types of predictions that science had made. And science also, I mean, routinely, if any of you are scientists, you know routinely that we don't say this is what's going to happen. We say it's going to happen probably within this level or this level at a 95 or a 99 or some other percentage. So there's a gap, and the focus then was on this gap. And the focus was on the word uncertainty. In scientific terms, uncertainty is a definition of the probability of it happening within a certain percentage of times that this might occur over repeated events of the same type. To an ordinary person, uncertainty means you're not quite sure what you're talking about. And that was what hinged, or what was the hinge point for the Exxon and Shell executives. But nevertheless, some of that got through, and so we can look at what are the mechanisms today to understand the science. Well, the first one might be schools, but schools really focus not so much on current science, they focus on old science. Textbooks are the currency of schools, and they basically are focused on science that's usually anywhere from 10 to 40 years old. A lot of the textbooks that we get in schools now have science that is at least 20 years old and often considerably older than that. So current science is just not a part of the school curriculum, particularly for lower grades and even in undergraduate school in university. So these people who are, the ordinary citizens of the world, they can't really be expected to understand the most recent current science. They have been imbued with what is science from quite a number of years ago. But there's another organization that can do this. This is, I take a certain amount of pride in this. I was president of this organization for some 13 years. This is the Canadian Museum of Nature here in Ottawa. And this kind of an organization can do a lot of basic research. Museums often house quite a number of scientists. In my day, this museum had about 75 to 100 scientists, and they were working on primarily biological information. It was primarily the naming and classification of species with a very minor intent to look at the ecology, so that the basic research knowledge in a museum is not about climate science, but it's definitely about the kinds of things that climate change affects. For example, biodiversity loss was a major concern of the museum here. And in the time that I was there, we would often talk about this. And just to explain, even though this is funded by the national government, our federal government here, we did not have access automatically to the politicians. I squeezed myself in often to Senate committees or parliamentary committees to make testimony and talk about these kinds of things. And I remember when the Biodiversity Convention was being considered early on, in the early 90s, I actually crashed one of the committee meetings where they were deciding who was going to be the representatives for Canada to go to this convention. They were all lawyers. Almost no country, literally no country, had a scientist. So I pushed one of our scientists in there, and he became the kind of eminence grise for the Biodiversity Convention. And that's really one of the reasons why, and he was one of only a very, very few scientists who were there. That's one of the reasons why that happened. But remember, that was not because this institution is a part of the general aspect of focusing on science by the government. It was just because somebody like me took a particular interest in it. Well, who else does this kind of work? Don't know if you're familiar with these guys, but Bill Nye, the science guy, and Neil deGrasse Tyson, the astronomical genius who often is a superb communicator. Well, how many more of these can you guys think of? Not a whole lot. So there aren't very many people who are truly engaged, who are also capable of talking about these kinds of things. Now, Neil is capable because he deals with astronomy. Bill less so because he's an engineer. He hasn't worked with climate science. He is not a biologist. So he tries, and he does a good job for the most part, but every once in a while he gets hung up. But anyway, that's kind of one deal. These are informal popularizers. They're not necessarily people who are in the research field who know what's going on. There's another group too that is important to communicating science, and those are things like TED Talks. This one here. TED Talks, if you don't know them, are really good. These are talks that are put on by either the TED organization or by a local group who brings together a conference for a whole day. It's videotaped, and those records are put onto the internet, and they're hugely popular. Often they cover a broad range of topics, everything from social sciences, mathematics, to climate change, to who knows what. It's great. If you get a chance to look at some of these things, they're amazing. But not everybody knows about. How many people here knew about TED Talks? Pretty darn good, pretty darn good. There were a few who did not. They're really a wonderful, wonderful talk, and you guys are amazing. It's not very often I ask that question and I get more than a few hands go up. That's great. But if we think about it, then that's one. Another one is like these folks here. They've got their cell phones out and they're kind of looking at it, and they look at the news or the news feed, or they look at Facebook or Twitter or Instagram or one of those kinds of things, and that's where they get a lot of their information. It's important that they do that, but it's also not information that has any necessary filter. It's not necessarily accurate. The modern term of fake news is often really, really valid here. And so that's another one. Now, one of the best ones is probably the idea of a magazine that focuses on interpreting science to the general public. The one I focused on there was Discover. I don't know if you know that magazine, but it's a very nice magazine, and it's effective. The Scientific American is sort of like that, but it's a little bit more scientific. If you think of the National Geographic, they do some good stuff in that area too, but it's not really focused on science. How do we link current science to the public and also to policymakers? Well, guess what? Science hangs out there by itself. There is no formal organization, no formal system to take the science and interpret it to the public. We have schools, of course, we have universities, but those organizations are internally focused. They're not focused to the outside. There isn't anything out there to do this. Instead, what happens is that, using the earlier examples I just showed you, what we have is an informal system to explain current science. It includes the museums, the informal popularizers, social media of various kinds, and mainstream media, magazines of various sorts, newspapers, television, radio. And all of those things can be classified as entertainment. Ideas. Oh, Frances, my wife, corrected me. There is a good program called Ideas on CBC. Can you speak up so we can hear you a bit more?
Environmental NGOs.
TV Ontario was mentioned.
Yes.
Good.
And National Public Radio, NPR.
NPR, yes.
Now, those are really great examples of what?
Entertainment.
Right. Those are really good examples of entertainment that have done a pretty good job. But there's no formal quality control on them. There's no necessarily accurate system. Yes, you had a question?
There is in fact a link, but it's so embedded that you've ceased to see it. There's that huge corporate structure and other structures that convey the information, process it to their own liking, and convey it, which forms the nexus and the context within which we see other kinds of information.
Okay, that's actually.
Clarification questions now. Speeches shouldn't even occur later.
Well, okay, but it's an excellent point, because it does add to the clarity of what we're talking about. So what he's done is elucidate that there is a set of vested interests who take current science, manipulate it, and use it for their own purposes. That is not necessarily the kind of thing that we want to have happen, but it was a really good point. Okay,
Excuse me.
one more?
I think there is one other, probably not very well known source that everybody should be aware exists, and that's the Council of Canadian Academies.
Can you explain that a little bit more?
Okay, so this is,
Can you speak up too?
okay, so the Council of Canadian Academies is all of the big universities, and from time to time they will take on a topic, form a working group, study what the current science is, and publish it on their website. So for example, they did one about influenza when we had the H1N1 thing going around, and there were all kinds of pieces of advice that were given out in sort of 1918, 1919 time frame when we were dealing with the Spanish flu. And when we had H1N1 recently, all those same things were touted as the things to do in the face of flu, even though in 1918 we didn't even know about the existence of viruses. And here we were later knowing all about viruses and saying, well, you should just go and do the stuff that we did in 1918. All of which we knew didn't work.
Another great example, thank you, that's terrific. Okay, so we got a problem, and it's a big one. It's a really big one. So, in another sense, we have to ask the question, why don't scientists step up and interpret science to the public, and why don't they force themselves onto advisory committees? Well, you know what? That's not easy. For the most part, you can't just walk into an advisory committee. You have to be invited. And unless you are relatively politically savvy, it's really hard to get invited to an advisory committee. You're often not the journeyman scientist. You have to be somebody who's already politically clicked in somehow. And not only that, I don't know how many of you here have an academic background in the sense that you've been in the research area for Publish or Perish? Quite a few. Okay, that's great. I'm going to have a really solid background of information here. When you do this outreach, when you do get out and talk, when you do all this kind of extra work, whether it's for television or you're doing public speaking or that sort of thing, it costs time. It takes time away from your research, takes time away from your teaching, takes time away from all of those kinds of things that are important. And I'll show you why they're important. The other thing that happens to somebody who gets out there is they get criticized because they are becoming an advocate. And how can you be an advocate and still be objective in a scientific format? You've already taken a partisan position once you do that. So it's really difficult for somebody who is a scientist to step out, particularly early in their careers, and take the chance of losing all that. Well, here's just to push it a little further, and I think this is really important here. I don't know, you're a great audience because you've had this kind of experience, but the academic requirements for advancement are really clear. You can look them up on any of the university websites. You have teaching duties. You have research duties. You have to create peer-reviewed publications. Not popular ones, peer-reviewed publications in technical journals. You have to acquire significant grant money. If you don't, you go pushed way back down on the list because the universities need that grant money. And the reason they need it is they take a percentage off the top. Often the percentage, particularly in some other countries, is really high, can be as high as 100%, so that you have to apply for twice the amount of money that you need to have. Well, that's not easy to do. There's university duties. You have to work on committees, you have to be part of different organizations and all that sort of stuff. And the only community work that you get benefit for is if it also benefits the university. Yes?
I just wanted to mention we were on a U of T cruise recently, and they now have created teaching-only positions, and I wonder if that would help.
Teaching-only positions. Okay, the question she asked was,
With the researchers.
yeah, does a teaching-only position within the University of Toronto where they take people on cruises, does that solve some of this problem? Yes, maybe a little bit, but not really, because those people are actually teaching from textbooks. They're not the primary researchers. They're not the ones that are actually dragging the information forward. It's a good thing to do, but it is definitely not the kind of science communication that solves that problem. Good point, though. So if you look at all of that, there's nothing in here that says you get career advancement, you can put this on your tenure application. None of this stuff includes talking to the public. None of this stuff talks about interpreting the science to the public or to advisory committees. Some scientists do it anyway. I mean, some scientists are out there and they're talking about science and they're pushing their way into advisory committees. Some of them have made some really important activities come to the fore so that they become public. But it's really not easy to do. Well, you might ask, well, who are these people and what are they like? I thought I'd show you a few examples. Now, these are people who are at the forefront of science, but they're willing to take the risk to go out there and reduce their scientific, or at least their career advancement to some extent, and do this kind of interpretation. Well, here's some of them. This is Dr. Jen Heemstra. She, and I'll just read her quote. She says, "Why do we treat science communication as a separate career option? As an academic, I spend most of my time talking about science or writing about science." And she says, grad students, if your program isn't teaching science communication, the short form is SciComm, you're missing out on a key skill for most PhD jobs. Well, she's right and she's wrong. Because the only way that's going to work is if the fundamental structure of academia shifts to allow science communication as part of the advancement technique or advancement in your careers that you can take on as a scientist. If that's not there, it's always a risk. Here's another one. This is Dr. Peter Gleich. He's an outspoken advocate for science-based policy. He did a neat thing, got him into a lot of trouble. He passed himself off as a denier and infiltrated one of the climate denier groups. And because he did that and he was discovered or whatever, his credibility fell down rapidly, at least with a lot of the people who don't like scientists, because he had, in their view, been dishonest. At this particular time, he was asked to be the keynote speaker at a climate and peace session at the Nobel Peace Prize Forum. And he offers at the bottom to come on in and say hello. So he's a neat guy, and he's a very effective communicator. Simon Donner is another guy who's right at the forefront of science. He said, this piece of news is real. This is real news. It's not fake news. According to North Carolina state law, you are not allowed to consider sea level rise in planning coastal infrastructure. If this law is not overturned, he says, this will eventually cost lives. Guess what happened? North Carolina and South Carolina have lost lives, a lot of lives. They wouldn't have done this if North Carolina, if Texas had understood that this kind of flooding would get worse and worse and make preparations for it. Instead, what they do is they put a lot of pavement everywhere, which means that the water doesn't have anywhere to go, and it just builds up. Here's another. She says, highlighting the ways science fails to be inclusive and equitable is important. But we can't do that at the expense of highlighting the amazing work women and minorities have put in to make it better. Now, what she's pointing to is a piece of the Me Too movement. The idea here is that in a lot of academic situations, and I would say particularly in the terms of advancement, women and minorities are at a real disadvantage. So it's hard for them to move forward, harder than for men. I remember an experiment that was done, this is a number of years ago. A group of professors made up a series of resumes that were identical except for the name at the top of each resume. They're absolutely identical. And they sent these off to the various universities who were advertising for jobs. Even though they were identical, the percentage of those that received the invitation to come and talk were those that had the male name. It was something like 80% in favor of males, even though the resume was identical. So it's really a problem. The way musicians got around it for orchestras was that they started having blind auditions. And it made a huge difference, just an absolute huge difference. Well, it's hard to do that for a science person because you actually have to come and give talks and all that sort of thing. So anyway, that is a serious problem in the academic community. Eric Holthaus is also a really interesting guy. He's a meteorologist. And he makes this comment, this is very recent. He says, Florence has now broken the all-time North Carolina hurricane rainfall record. It has also broken the all-time rainfall record for any East Coast state north of Florida. And at the time he wrote this, he says, and it is still raining. The other thing about Eric is that he's a religious man, and he takes great pride in that, and he's been celebrating the names of those who perished in Puerto Rico, either during the hurricane or afterwards. So he's a really neat guy that way. But he does get into trouble for that kind of thing. Here's another one. This is Dr. Kate Marvel. Her name is kind of fun, and she sometimes gets teased as being Captain Marvel from the Marvel comic books, but she actually has no relationship there. But her comment is interesting too. She says about often the notion that, and you'll see more of this as I go forward, that we scientists feel like we're kind of unloved, that we're not really good folks for everybody. But she says, no. She says, hey scientists, I know it sometimes doesn't feel like it, but most people actually like us and trust us. Climate science says hurricanes get stronger, rainfall more intense, and storm surges higher in a warming world. We can't change physics, but how we treat each other, that's up to us. So she's talking about the internal workings of climate science and of academics in general. We need to support each other if we're going to be able to move forward like this. And she's also pushing for science communication to be part of the advancement criteria for career academic. Carolyn Porcaro is another really interesting person. She's been the leading scientist on imaging for the Cassini mission that was in orbit around Saturn from 2004 to 2017. It was really interesting to read her reaction when Cassini finally crashed into the Saturn things. And she's authored a lot of papers, something like 125 scientific papers on astronomy, planetary science, and she's a regular public communicator on science, astronomy, planetary exploration, and the intersection of science and religion. Now that's something that also becomes really important if you're trying to advocate a position on any kind of a controversial subject. For instance, her work deals in part with the origin of the universe. And from a scientific perspective, the origin of the universe is perfectly explainable without the need for any higher power. I mean, it doesn't say there isn't one, but it says, at least within the scientific context, you don't need that higher power. What this leads to is people ganging up on her and denying that this is the truth, that she can't be right, and then that spills over into other kinds of controversial subjects. So it doesn't stay with the origin of the universe. It says, I don't believe in evolution because you guys are saying that there's no higher power out there. I don't believe that we can affect climate change in the world. It's way too big for us. And besides, the God, whoever God you believe in, is going to be responsible for the apocalypse, not us. Now, you know, when you're faced with this, it's not funny. It's really serious because, you know, you have to answer those questions. And while to many people, the concept that you can think like this is straightforward, obvious. This is the way it is. We believe this, and that's perfectly okay. The problem then becomes these kinds of belief structures actually get pushed into the policies of today. Here's another one. She's Rachel Livermore. Dr. Rachel Livermore is also an astrophysicist, and she's suffered a fair amount from the kind of abuse that you get when you do these things. But she says, I believe strongly that taxpayer-funded research should be communicated to the public in an understandable and engaging manner. I have therefore been heavily involved in both organizing and participating in astronomy outreach events. Her career is now in question. I doubt very much that she'll stay as an astrophysicist. It's been so abusive for her. Corinne Bondar is a Canadian scientist, and she has popularized the whole idea of this in a very fun way. She has a whole series of TV shows, and one of those is called Outrageous Acts of Science. She has a website that focuses on sex in organisms. It's all really fun. Okay, so why do they do this? Well, because global warming is really important for them. They feel that it's worth the loss of their potential career advancement. Why do they think this? Because temperature is continuing to go up. There's no reason why we should see it stop. As the carbon emissions go up, that's the blue line on top, the carbon dioxide that stays in the atmosphere also goes up. When the atmospheric temperature and the CO2 are combined together, you'll see that there's a very, very tight correlation. Sea level is also going up, and it's accelerating. It's not slowing down. I'm showing you this graph because it compares the amount of temperature increase with the amount of CO2. So they're very, very tightly related. That relationship makes carbon dioxide a pretty good predictor for what's going to happen in the future. The Paris Agreements are an important part of the global intent to control climate change. And what I've done is I've taken the actual pledges that are in the Paris Agreement, and they're on two levels. They're high and low and median. So I've compared what is going to happen in the future by deriving an equation to predict from the actual data that is in the Paris pledges what could happen if we did one of those three things. So just for example, I chose the middle section, the median. And what happens here is that we peak and reach zero emissions somewhere around 2100, 2150, and then we carry on reducing the atmospheric carbon dioxide down to about 320 parts per million, trying to stay at the 2 degrees Celsius limit. That's what our activity would look like. Now what happens to temperature? Well, temperature goes up in this case. Now this is the Paris pledges, the median level. The temperature would probably go up to about 12 degrees Celsius, above what it is today. Well, that's huge. Now for a couple of people here, I think I need to explain that this is not perfectly accurate science. Bill Pugsley here would argue with me that there's no way to predict the actual temperature. And I agree with him 100%. But there is a good way to predict a fairly close relationship. It's not terrible, it's not great. These are based on proxy temperature and carbon dioxide measurements. They're not perfect, but this is probably not bad. So it'll be around 12, could be 10, could be to 14, somewhere around 12 degrees. That's a huge amount. The two lines here are because if you look at the geological record, it takes a long time to cool down, anywhere from 4 to 11 times. So the blue line here, this would be the most rapid you'd be able to see it normally.
4 to 11 what?
Times as long as the warm-up period. So if it took 200 years to warm up, it'd be taking 800 years to cool off. That's the idea. And with sea level, we have the same kind of a problem. And that is that it takes a lot longer for the sea level to rise, but it also takes a long time for it to cool, for it to decide to go down again. And the reason for that is you have to cool off the ocean. And that's a big job. It's kind of like that bucket of water I mentioned at the beginning. But in terms of sea level, you not only have to cool it down, but you actually have to have it cold enough at some parts where it snows enough to form new glaciers and new polar ice caps. And that takes us out into the year around 3000. Now those effects are locked in by what we do in the next 50 to 100 years. So if we don't change our behavior in the next 50 years, this is what's, well, even if we do, to meet the Paris Agreement, this is what's going to happen. If we look at this on a global scale, the dark brown parts of the map here are areas that really won't support human life. The brown parts, the lighter brown parts, are essentially desert or very, very dry areas. And the green parts are the parts of the world that will remain warm without being too hot, but the Arctic, under these same kinds of conditions, would ultimately become subtropical or tropical. And if you think about it, most of the people in the world live where the brown stuff is. So most of the people in the world are going to move to where we are, right here. If you think about Canada, what do we have in the way of ability to support that kind of migration? Well, we've got areas here that will become more agriculturally possible, but we also have mountains and the Canadian Shield that make it difficult to have agriculture in those areas. Still, Canada would have the ability to probably sustain something like 1 billion people, something like that. So the benefit to science, or benefit of correct science, is good decisions for public and policy, but that doesn't always happen. There's some folks out there who really are just not interested in that answer. Okay, I'm gonna jump ahead a little bit. Charlotte Observer, this is just a few days ago. 30,000 people volunteer to shoot Hurricane Florence. Shoot with guns, shotguns, rifles, whatever. And the Charlotte Observer, the reporter wrote, "Do not actually discharge firearms into the air. You could kill someone, and you cannot frighten a hurricane." And then he carries on, "I can't believe I actually have to write this." Okay, here's some, on social media, people talk to me. Here's one of the things they said. "There's nothing wrong with fossil fuel. It's only a demon in alarmist heads. Now, dirty polluted air, that's different. CO2 is not a problem. We need it. The recent global warming, as you put it, is completely natural. Humanity has benefited from a warming climate. The ecological system functions better in warm than when it's cold. I know," they say, this was in response to me again, "but water vapor covers nearly all the CO2 spectrum. The atmosphere is already opaque. Adding more CO2 is just like putting a sheer curtain in front of blackout drapes." That's a technical point, which I won't bother with right now. But then, if we think about somebody else here, 120 years ago, St. Arrhenius said that global warming was real, and here's how it happens. Now this is 120 years from then, Donald Trump, who is elected the President of the United States, says global warming is a Chinese hoax. Beautiful. Coal is the best fuel, he says. We need to reinvent coal. Justin Trudeau, 1988, 30 years after the presentation by James Hansen, he announces the purchase of the Trans Mountain Pipeline, emphasizing it's important to sell all of the fossil fuels in Canada's vast resources to preserve the economy of Canada and become an energy giant. Well, if we translate that into the policy for the entire world, that is a full-scale disaster. One of the most famous people in this game was Michael Mann, and he was the first one to chart the history of climate change over the last couple of thousand years and point out that in the last 200 years, the temperature has just shot up. That was called the hockey stick. He's been accused of fraud, been accused of data manipulation, he's been threatened with violence and with death. Sarah Meyer, she's another one of these people who's willing to step up and stand up for what she believes in. And at this point, she says, I've just learned something so scary, and I'll just say this. There is a special place in hell reserved for scientists who broker climate denialism for their personal gain. Generations will look back on your actions, and you'll be remembered as evil and self-serving. Now, she's a young woman. She's a single mom, and she has a child. And she says, in science, we see students urged to participate in science communication. Then she goes on, I guess I should be prepared to be trolled for being a woman, a feminist, scientist, advocate, and socialist. I love the internet. Sigh. But then she says in a follow-up tweet a couple of days later, what do you do when crazy people stalk you and your child? And the way they do that is because she's a university professor, they can find out who she is, what her home address is, what her telephone number is, and that's called doxing. And they advertise this through the dark web or even through the ordinary internet. And so people can come actually to her front door and leave signs or throw rocks through the window, that sort of thing. So some of these people have actually had to move. Here's probably the most famous. This is Dr. Katharine Hayhoe. She's an evangelical Christian and works closely with the evangelical Christian community. She's a Canadian climate scientist. She says, we don't talk about it much, but we get this every day. The last few days, I was told I'm I'll let you fill it in, a liar, full of bullshit, and that I have a fake degree. Most other women have similar experiences, yet still we persevere. Who attacks these people? Who is it that does this? Well, often these are people who are themselves scientists. For example, Dr. Roy Spencer is a he's not really a climate scientist in the formal sense, but he measures the satellite temperatures, or at least he doesn't measure it, but he interprets the satellite temperatures. And he happens to be a person who is a creationist. He doesn't believe in global evolution. He doesn't believe in climate science or climate change as being caused by humans. So he often is called on by politicians and newspapers to talk about this kind of a problem. Dr. Patrick Moore is a Canadian. He's an ecologist. He was one who claims to be a co-founder of Greenpeace, although Greenpeace doesn't agree with them. And he says that the terms climate science and climate scientists are part of identity politics. He says if you disagree with the litany of climate science, you're not a true climate scientist, you are a climate denier. I can go on forever here with these guys, but here's another one where he says, where will global warming run away to, and can it take all the climate bedwetters with it? Then he says, what's wrong with fixing global warming? Nothing. The world burns more and more coal, oil, and gas. The standards of living increases globally. Atmospheric increase of CO2, plants thrive. What's not to like? He's saying, leave it alone. Carry on. Tom Nelson is a prolific social media guy, and he's just amazing. Okay, these are direct comments to Catherine McKenna, who is our minister, and she said they say to him, well, maybe you should be on the tarmac when the fuel truck fills the plane with pixie dust and unicorn piss.
These are comments to her, not by her.
No, these are comments to her, not by her. And then in reality, all she will do is waste time flying everywhere for photo ops and spewing nonsense. That's our top-notch environment minister at work. Here's another one. This is not Catherine McKenna. This is a parody account with almost the same name. And in this one, what the idea is to sort of screw up her own comments, and what this parody account does is reword her words so that they sound ridiculous. This is another climate account for her. It's called Climate Barbie. And the picture here is labeled Climate Barbie and her staff. And of course, there's a whole lot of pigs digging in a trough. And this is Climate Barbie again, picking up on a couple of her comments. Puffins are not penguins and that sort of thing. Trying to make fun of her, trying to undermine her credibility, trying to make it so that she cannot actually propose anything. So, what do we do next? How do we solve this problem? We as scientists have done a lot. Can we do more? Is there something that the community at large can change so that we have a better mechanism of communicating science to the general public and to policymakers? Thank you very much.